listeners and viewers. Welcome to Kaduna State Ministry of Education Radio and TV e-learning program designed for our SS3 and other students staying at home due to the coronavirus pandemic. The present administration, under the able leadership of His Excellency, Malam Nasir Ahmed El-Rufai, is positioned, as always, to ensure that under his leadership, our students are not left behind in all areas of human endeavors, especially education. Kaduna State is the center of learning. Therefore, we want to ensure that our students excel in their forthcoming examinations and beyond. Students and other learners at home are given this opportunity in order to continue learning, as education is a continuous process. Different subjects will be taught in this program to assist students to perform excellently in the forthcoming Senior School Certificate examination being conducted by NECO and WAEC as soon as schools reopen. Teachers making presentations will always provide their names and phone numbers during each presentation, and they can be contacted for questions, further explanations, and/or clarifications. The following numbers and contacts can also be reached for expression of any concern or observation: 090-865-00545 or 080-383-62072. Our website is www.education.kdsg.gov.ng. Our email education@kdsg.gov.ng or education.kdsg@gmail.com. Our YouTube channel, Ministry of Education, Kaduna State. Our Twitter handle @Kaduna_MOE. Or our Facebook page, Ministry of Education, Kaduna State. Stay safe, stay at home, and learn well. Thank you, happy listening, and happy viewing.
Hello, listeners and viewers. You're welcome to yet another exciting moment of our e-learning. My name is Mr. Monday Bokoy. I'm here to take you through next segment of study, and the subject, as you can see, is mathematics, and the topic for our discussion this present moment is sequences and series. Sequences and series. By definition, a sequence could be defined as any set of numbers written in a defined order by which all the terms are obtained. When the terms of a sequence are added, the resulting expression is called series. Now let's cite examples so that we can be able to comprehend the definition very well. The following set of numbers are sequences. Look at A. We have 1, 4, 7, 10. If you observe, the difference between each of the terms is unified. The difference between 1 and 4 is the same thing as the difference between 4 and 7, and so on and so forth. If you add 3 to 1, you have 4. That same 3 you add to 4, you have 7. That 7 you add 3, you get 10, and so on and so forth. So there is a constant value. There is a constant addition of a simple term. That is the common rule. You keep adding 3, 3, 3, you obtain the next term. Look at example B. We have 2, 4, 8, 16. The terms are obtained by multiplying each preceding by 2. If you take the first term, which is 2, 2 multiplied by 2, you get 4. 8 multiplied by 2, you get 16. 16 multiplied by 2, you get 32, so on and so forth. So the common value that is used there is a ratio of 2. You keep multiplying and you get the next subsequent term. 2 by 2 you have 4, 4 by 2 you have 8, and 8 by 2 you have 16. Example C, if you observe, we have 15, 11, 7, 3. There is a deduction of the terms as you are moving ahead. The first one is 15. When you subtract 4, you get 11. When you subtract 4, you also get 7. When you subtract 4, you equally get 3. So there is a constant term. There is a constant rule. The sequence has been obeyed. Now, if we look at example D, we have -3, we have -7, -11, -15, so on and so forth. There is a constant reduction of 4. If you have -3, -4, you have -7. That same -7, -4, you have -11. If you equally move ahead, -11, -4, you have -15. So you can generate so many times as far as possible because you know the constant rule that is applied. And the last one, E, we have 1, 4, 9, 16, so on and so forth. The definite rule applied there is the squares of all numbers. If we take the first one as 1, 1 times 1, you will get 1. The next term, 2, 2 multiplied by itself, you will get 2 or 4. Then the next term, 3 by itself, you will get 9. And then 4 times 4, you will get 16. If you want to get the next term is 5. 5 times 5, you will get 25. So on and so forth. So the simple rule there is you square all the terms of the natural numbers. Now look at the example of a series. The following are example of series. Just like I've earlier defined that when the terms of a sequence are added, the sequence becomes a series. So observe the terms very well. The first was 1, 4, 7, 10. When we add them together, you will have 1 plus 4 plus 7 plus 10. That becomes a series. Look at B. We also have 2, 4, 8, 16. When you sum them up, we have 2 plus 4 plus 8 plus 16 plus dash, dash, dash. It becomes a series. Look at example C. We have 15 plus 11 plus 7 plus 3 plus dash, dash, and so on and so forth. When you sum them up, it becomes a series. Example D, we are having -3 plus -7 plus -11 plus -15 plus so on and so forth. It has become a series. Now look at the last example. We are having 1, 4, 9, 16. When you sum them up, we have 1 plus 4 plus 9 plus 16 plus so on and so forth. It becomes a series. So you should take note very well that a sequence and a series, a distinctive factor is that the sum of any sequence gives rise to a series. Then we move to the next, and we have the nth term of a sequence. What is an nth term of a sequence? The nth term of a sequence is the rule or a formula used in obtaining the terms of the sequence. I repeat again, if you have the nth term of a sequence, is the rule or formula used in obtaining the terms of the sequence. The nth term is written as T subscript n or U subscript n. That is the nth term. Tn or Un. It is the formula for the nth term. Now let's cite examples so that we can be able to apply and see how we can generate our terms. Example, we have the examples as follows. Find the first, second, and 10 terms of the sequence whose n terms is A, 1. Tn is equal to 2n minus 1. 2. Tn is equal to n raised to power 3 plus 2. Solution number 1. The n term is giving us Tn equals to 2n minus 1. Therefore, from the question we are expected to find the first term. So my T1, that is when n is 1. You have 2 multiplying 1 minus 1. And 2 times 1, you have 2. Then 2 minus 1, the final answer is 1. Therefore, the first term of the sequence is 1. We move to the second term as requested. T2 will be equals to 2 multiplied by 2 minus 1, because the n term has been given. So 2 times 2, the result is 4. And 4 minus 1, you get 3. We move ahead. The instruction is we are equally to find the 10th term. So the 10th term is when n is 10. So T10 equals to 2 times 10 minus 1. And 2 times 10, you will get 20. And 20 minus 1, the final answer is 19. Example 2, the n term is given as Tn equals to n raised to power 3 plus 2. We are expected to find the first term. Therefore, our T1 will be equals to 1 raised to power 3 plus 2. And student, to take note, 1 raised to power 3 does not mean 1 multiplying 3, no. But 1 multiplying itself in 3 places. So 1 cube will now give us 1 times 1 times 1 plus 2. And 1 multiplying 1 times 1, the result is 1. And 1 plus 1, you will get 3. So our first term, which is T1, is equal to 3. We move to the next, which is the second term, T2. My T2 will be 2 raised to power 3 plus 2, because our n now is 2. So when you replace n in the formula as 2, you get 2 raised to power 3 plus 2. Then 2 raised to power 3, as I've earlier warned, it is not 2 times 3, but 2 in 3 places. So we have 2 multiplying 2 multiplying 2 plus 2. And 2 times 2 times 2 equals to 8. 8 plus 2 will finally give us 10. So our second term of the sequence is 10. Then the 10th term, which is T10, will give us 10 raised to power 3 plus 2. And 10 raised to power 3 will be 10 multiplying 10 multiplying 10, then plus 2. And 10 times 10, you will get 100. 100 times 10, you will get 1,000. Now 1,000 plus 2, you will get 1,002. 1,002. Now we move to types of sequences. Types of sequences. For ordinary level, we have 2 types of sequences, namely 1, a linear sequence, or arithmetic progression, abbreviated as AP. 2, we have exponential sequence, or the geometric progression, abbreviated as GP. What is a linear sequence? A linear sequence or an arithmetic progression is a sequence in which the terms either increase or decrease in equal steps. The equal steps of increase or decrease is called the common difference of the sequence. It is denoted by letter D, while the first term of the sequence is denoted by letter A. And we should take note that to derive or to deduce your common difference, our D is T2 minus T1, or T3 minus T2, so on and so forth. Now, let's cite examples so so that we can be able to use the formula and be able to solve any required number of terms as requested from the question. In each of the following linear sequence, we are expected to find the common difference. What is the common difference between terms? We have question 1, 8, 12, 16. Question 2, we have -5, -11, and -17. Solution. What is our D, which is the common difference? Our common difference, D, will be equal to T2 minus T1. And from the sequence, you can have the first term is 8, the second term is 12, and the third term is 16. So T2 is 12. You replace minus T1, which is 8. If you have 12 minus 8, the result is 4. So our common difference, as you can see, is 4. So if you keep adding 4, you generate terms as so on and so forth. That is why you have 4 plus 8 is 12. 12 plus 4, you have 16. If you want the next term, will be 16 plus 4, 20, so on and so forth. Example 2, we are expected to find the common difference of the sequence -5, -11, -17. What is our common difference? Our common difference, D, is equal to T2 minus T1. T2 minus T1. And our second term is -11, while the first term is -5. Take note, the first term is -5, so you have to put it in bracket, so that you have -11 minus will give us plus 5. So -11 plus 5 will give us -6. The next is the nth term of an arithmetic progression. The nth term of an arithmetic progression. The nth term of an arithmetic progression is given by the formula Tn is equal to 1a plus n minus 1 bracket d, or un is equal to a plus n minus 1 bracket d. Un equals to a plus n minus 1 bracket d. In this case, our a is the first term, while our d is the common difference. So if we want to generate terms like the first one, we have T1 equals to a plus 1 minus 1 bracket d is equals to a plus 1 minus 1, you have 0. And 0 multiplying d is still 0. So a plus 0 is 0. That is why our first term is T1, which is equals to a. T2, if you observe very well, it will be a plus 2 minus 1 in bracket d, and is equals to a plus 2 minus 1, you will get 1. And 1 multiplying d is still d. So the second term, which is T2, will be a plus d. Move to the third term. Anywhere you see n, you replace the value of the variable. So Tn or T3 will be equals to a plus 3 minus 1 in bracket d, and it will give us a plus 3 minus 1 is 2, and 2 times d is 2d. So our third term is a plus 2d. Let's move to fourth term, which is T4. Our T4 will give us a plus 4 minus 1 in bracket d. It will give us a plus 4 minus 1 is 3. And 3 times d, you will get 3d. So our fourth term is a plus 3d. And then we move to the fifth term, which is T5. It will give us a plus 5 minus 1 in bracket d. It will be equals to a plus 5 minus 1 is 4. And 4 times d, you have 4d. So our T5 will be a plus 4d, and it is generated so on and so forth. If you want 1 million term, you replace n with 1 million. If you want any term, you can replace. That is the nth term of an arithmetic progression. Let's cite examples. So in each of the following APs, we are expected to find the a 8th term, B, 100th term, C, the nth term. Again, A, 8th term, B, 100th term, C, the nth term. Solution, we have the first one as 7, 10, 13. All you need to do is to deduce the terms, the variables, and our A is the first term. The first term in the sequence, as you can see, is 7. While D, the common difference, will be T2 minus T1, which is 10 minus 7. The second term is 10, and the first term is 7. So 10 minus 7 will give us 3. Now, given the formula as our nth term, Tn is equals to A plus n minus 1, bracket D. Therefore, we are to find the h term, T8 equals to 7 plus 8 minus 1. 8 minus 1 in bracket D. Our A is 7, so we have replaced A with 7. Our common difference is 3. We equally replace our common difference with 3. And then n term, which is 8, is n, 8 minus 1, bracket D. So we now have 7 plus 8 minus 1 in bracket 3. If you subtract that, 8 minus 1, you have 7. Opening the bracket, 7 plus 7 times 3, you have 21. So if you sum them up, you have 7 plus 21 equals to 28. So our 8th term of the sequence is equals to 28. Now we move to the 100th term as requested. T100 equals to 7, which is the first term, plus 100 minus 1 is the nth term, and then multiplying 3. Then 100 minus 1, you will get 99. So we'll be having 7 plus 99 times 3. If you multiply that, you have 297. So 297 plus 7, you have 304. And then the last one is the nth term. And I told you earlier from definition, nth term is the formula used in obtaining the terms of the sequence. So our Tn in this case will be 7 plus n minus 1 in bracket D. So that 3 is multiplying each term in the bracket. So we expand and we have 7 plus 3 times n, you have 3n. 3 times 1, you have 3. Plus and minus, you have minus. Now you collect like terms. We have 7 minus 3 plus 3n. And 7 minus 3, we'll be having 4. So our n term will be Tn equals to 4 plus 3n. My student, my listeners, if you just pick any term and substitute using this formula, you have your correct answer. Take for example, the first term is 7. So when n is 1, so use T1, 4 plus 3 times 1 is 3. So 4 plus 3, you get 7. If you are looking for the second term, when n is 2, you have 4 plus 3 times 2. And 3 times 2 is 6. So 4 plus 6, you have 10. So on and so forth. This is the formula used in obtaining the terms of the sequence. Next, example 2, we have 5, 1, minus 3. The first term is 5. Our common difference is T2 minus T1 and is equals to 1 minus 5. 1 minus 5 will give us minus 4. But we have the formula as Tn equals to A plus n minus 1 in bracket D. Tn or Un equals to A plus n minus 1 in bracket multiplying D. Therefore, A, we have to find the h term, T8 will be equals to 5 plus 8 minus 1 in bracket minus 4. So 5 plus 8 minus 1, we are having 7. And then you multiply 7 by minus 4. The result is 28, because plus minus we will have minus. Positive times negative, the result is negative. So we are having 5 minus 28. And 5 minus 28, you have minus 23. Minus 23, that is our 8th term. B, we'll find the 100th term. Our 100th term will be T100 equals to 5 plus 100 minus 1 multiplying minus 4, which is a common difference. So we have 5 plus 100 minus 1, you will get 99. And 99 multiplying minus 4, positive negative will give you negative. So you have minus 396. So 5 minus 396, the result is minus 391. And then C, which is the nth term, formula used in obtaining the sequence, Tn will be equals to 5 plus n minus 1 bracket minus 4. So we have 5, when expanding the bracket, minus 4 times n, you have minus 4n. Then minus 4 multiplying minus 1, you have plus 4, because negative will be positive. So collecting like terms, 5 plus 4 now will give us 9. 9 minus 4n. So the nth term of the sequence, Tn, is equals to 9 minus 4n. If you substitute the terms, you get your answers correct. Before we conclude the lesson, I will leave an assignment for you so that you can be able to digest by practicing them. As you can see, the lockdown is still on. It will keep you busy, and you keep practicing, preparing for your forthcoming examination. Question 1. Given the arithmetic progression 12, 15, 18, dash, 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 we are expected to find the A, common difference, B, the 10th term, C, the nth term of the sequence. Again, A, common difference, B, 10th term, C, the nth term of the sequence. Question 2, the nth term of a sequence is given by Tn equals n squared plus 3. Tn equals n squared plus 3. We are expected to find the first term, which is T1, the second term, which is T2, and the 20th term, which is T20. Finally, the last question, the 20th term of an arithmetic progression is 84. Find its first term if its common difference is minus 5. Now you have your reference material, the new general mathematics for SS3. You know, it's a series. We have SS1, SS2, but you are in WAEC level. The SS3 student, we use new general mathematics SS3 by J.B. Chanom. And then question 2, we use question and answers, Q&A, the past questions and answers, related problems in WAEC, NECO, and if possible, JAM. So these are our reference materials. Once again, listeners, learners, you can still contact me if you encounter any difficulty with my number 080 25 25 9755. I remain Mr. Monday Bakwe. Wish you the best.